Hello, right, I'm going to finish this series of videos by talking about how we estimate the median and estimate the quartiles from grouped data. So before I begin, there are just two things I want to say. The first is my preferred method will be to involve sketching a histogram rather than using a cumulative frequency curve. Now I actually have, and I'll link them in the description, a couple of videos that I made. Well, let me just check when did this come out. Back in June 2020, I made two videos on cumulative frequency graphs. This was for last year's year 10, but all the stuff in there is still very much relevant, right? How do you draw a cumulative frequency graph? How do you use it to estimate the median? How do you use it to estimate the quartiles, etc.? So if you need to revise that and you need to review that, then please go and watch those videos. I'm going to focus on using a histogram to do it in this video, and it's also what I would have done in school as well. My definite preference is that we sketch a histogram rather than sketch a cumulative frequency graph. I think it's easier to, first of all, I think it's easier to sketch. And I'll show you quite a few examples of me doing it. And I also think it's easier to work out what the estimate would be based on the picture, where I think it can be a bit harder with a cumulative frequency graph. So that's the first thing I'll say. The other thing I'll say is just a reminder from the previous two videos that we basically, it boils down to two questions. Where is the median versus estimating the median? Okay, so and the quartiles. And the point is if we're asking where is the median, and we actually have a list of numbers, or we have a frequency table that isn't grouped, it's a one where we could actually write down what all the numbers are in order, then it would not be an estimate, and we could actually find where the median is and work it out. And we could do the same with the quartiles. And then remember, we've got these two different methods. One, which was in red, was find the median, cut the data in half, find the median of the bottom half, find the median of the top half. Those are your quartiles. That was what was taught at GCSE. And then there's this other method for locating the median and for locating the quartiles, which is the one presented in the A-level book, this one, which gives you the same answer as the other method, except for the quartiles when n is 2 more than a multiple of 4. Does it matter? No. Do I have a preference? Yes, I prefer the red method. That's what I think is better. But you can use either. You can use either in the exam. And again, if I have grouped data and I'm asking where is it, it's still a question of, okay, what's the total frequency, right? Whereabouts would that data point be? Which group would they be in? So that would still fall under the use of either using this approach, this blue approach, this one that uses n+1. So that was covered back in the second video. Whereas in this video, what we're actually going to do is we're going to look at this sort of second question, which says estimating the median and estimating the quartiles. And we're going to do that for grouped data. So it really will be an estimate. Now, if you remember from last time, if we said where is the median, so if the question was where is the median, where is it? Well, you would do 4 add 5 is 9, add 7 is 16, add 10 is 26, 26 add 1 is 27, halved is 13.5, so we're halfway between the 13th and the 14th, right? That is me applying that n+1 thing, but that is not me estimating the median. That is me saying whereabouts should it be. So it would be in this one, the 7 to 8, okay? Because that's where the 13th and the 14th data point would be, right? They'd be in this group here, this group of 7. Right, we don't know what they'd be, and we don't know, that's where the estimation comes into play, and that's the thing we're doing in this video. So with all of that out of the way, there's a little 5-minute introduction there. Let's begin. So the way you want to do this for continuous data is you want to sketch a histogram. So let me show you how to sketch a histogram. So what we want is we want to remember that the frequency is the area. We want to know that it's the area of a rectangle, so it has a width and a height. The width is what's called the class width. And the area will be the class width times the height. So if I do area divided by class width, I'm going to get the height. And remember what the height is? It's called the frequency density. Right? That's what it's called for a histogram. So the class width is just 2 in this situation. 7 take away 2 is 5. 8 take away 7 is 1. And 13 take away 8 is 5. And then 4 divided by 2 is 2. 5 divided by 5 is 1. 7 divided by 1 is 7. And 10 divided by 5 is 2. So, you know, sometimes you get decimals here, right? And sometimes you get horrible decimals. And it's even better to write them in an exact form as a simplified fraction. But here we've got nice numbers, so obviously that's nice. I am also going to go through this question that was in your test B, which was for your revision, for your assessment that you'll be doing on Thursday. Okay, so I think you'll probably get more horrible numbers popping out of this one. Anyway, how do I sketch a histogram? Well, I'm going to say the numbers along the bottom go 0, 2, 7, 8, and 13. And I'm not going to be that worried. I'm not going to be that worried about the spacing, right? Because it's a sketch. It's a sketch. So the numbers along the bottom are your 0, 2, 7, 8, and 13. Of course, that's really height. And these are all your class widths, right? So it's a width of 2, it's a width of 5, it's a width of 1, and it's a width of 5. And then what you do is you make them be however tall you want, and you do try to make it look fairly realistic, but you don't worry too much. So we're going to make this one be too tall, and I actually write the frequency density number kind of at the top of the bar there. So that's what I do, and then there'll be a 1 that goes there. So what this is just telling you how tall the rectangle is. This one here goes all the way up and is 7 tall. Notice it's not perfectly to scale, and as I say, it's just a sketch. The whole thing is just a sketch. You know, in the most extreme case, I just make them all the same height and just write the frequency densities on. But obviously, we want it to look fairly realistic, don't we? So that one was too tall. And then what's the idea? You've got 2 along, 2 up. 2 times 2 is the area is 4. 1 times 5 along is area of 5. So I put the areas inside and I circle them. 1 times 7 is 7. And 2 times 5 is 10. So the circled numbers need to be these numbers here. Okay, need to be these frequencies. And this is my sketch of my histogram. Okay, this is the sketch. There's not very much else to say. So that's actually something worth practicing, is just quickly sketching a histogram. Okay, because it helps you answer these questions. And if you can do that quickly, then great. So how are we going to first of all estimate the median? Well, if you've done your reading from the book and you didn't have any questions, then my assumption is you know how to do this. But let me go through it with you now. So what you want is you want to shade in from the left half the total area. That might be about there. I don't know. I'm just guessing right now. And then if I shade that in and it's half the area, then this number here would be my estimate of the median. Now that's not a very good guess what I've done there, because I can be a little bit more precise. First of all, the total area is the total frequency. So the total area is the total frequency, which is 26. So we actually want to shade an area of 13 from the left, right? From the left. Now, that's already an area of 4. That's already an area of 4. That's already an area of 5. So we've got 9 so far. And then 9 add 7 is 16. 9 add 7 is 16. So if I was to shade all of this box here, I would have actually shaded a frequency of 16, not 13. So what that tells you to do is, and it's still forming part of your sketch, and this is where maybe if I'd drawn this a bit bigger, it would be a bit better, but we'll go with it for now until it gets a bit cumbersome. So you basically are saying, look, I'm going to shade up to here, and 9, I would need 4 more. So I'm going to put 4 in there, and I'm going to say, look, I want this to have an area of 4, right? I want this to have an area of 4. So what I would have so far is 4 add 5 is 9, add 4 is 13. That's half of 26. Now I'm halving 26. I'm not adding 1 to 26 and then halving, because I'm not, that would be me locating the median. Okay, if I actually had all of these in a row, it'd be halfway between the 13th and the 14th number. Okay, this isn't that. This is actually getting an estimate for the median, an estimate. And the best estimate is whichever number it is along the height axis, because it's height in this question, that gives you exactly half the area, right? Gives you exactly half of the frequency, right? So that's what we want. And so the question is what is this number here? So it's some number between 7 and 8, right? It's some number between 7 and 8. And actually, it's possible to work it out. It's possible to work it out because if this has to have an area of 4 and it has a height of 7, so we worked out that it has to have an area of 4, and we already know that it's within a box that has a height of 7. So to work out how far along, I'm going to do 4 divided by 7. Right, that's going to be how far along it is. How wide is this blue rectangle here that I've got there? So it's 4/7. And then the last little thing to do is to realize that we've started at 7. So it's 7 plus this bit. So it's 7 plus 4/7. And 7 plus 4/7 is 7 and 4/7. So as a decimal, 7.57 is it to 2 decimal places, so 7.57. So what I need to do is go to the 7 that's here and add on the width that I've just worked out for this blue rectangle here that has an area of 4 and a height of 7. Well, the width would have to be 4/7. The area divided by the height will be the width. And that is that distance there added to 7 actually gives me this number here. So this number here, as I've just said, is about 7.57, right? I'm doing 7 add the 4/7. I'm doing 7 add the 4/7. Right. Now, in terms of estimating the quartiles, I will talk about how to do it, and then we'll model it for this question, because otherwise there's just going to be too much basically. So what you would want for the lower quartile is 1/4 of the area from the left. So you would do 26 divided by 4, because the total area is 26. So 26 divided by 4 is 6.5. So you would have 4, and then you would want an area of 2.5. Now, as it happens, since this box actually has an area of 5, I can actually say straight off what the estimate for the lower quartile is, because it will be halfway between 2 and 7, as it happens. Let me just sort of illustrate that. So 26, so for the lower quartile, I'm going to work out 26 over 4, which is 6.5. And what I want is a total area of 6.5. This will be my estimate for the lower quartile. And since that's 4, I'll be left with 2.5. And 2.5 is actually quite nice, as it happens, for this particular question, because, you know, it has a height of 1 and it needs to have an area of 2.5. So the width is 2.5. And I'd need to add that to 2. So it'll be 4.5, right? And that happens to be halfway between 2 and 7. So, okay, straight away I've got my lower quartile as 4.5. If I want the upper quartile, I would do 3/4 of the area from the left and, again, proceed from there, okay? I would... I'm not going to do that for this one just because I want to not make the video too long, and I want to use this as the actual sort of model solution here. So first of all, we're going to sketch our histogram. Now I'm going to put my sketch of my histogram here, down here. So we have a class width and we have a frequency density. Now the class width there is 5, is 3, is 2, is 5, is 5. Now, what I will say, look, if you'd prefer to do this with a cumulative frequency graph, to get these estimates as precise as we want, you would actually need to join each coordinate up with a straight line and actually do linear interpolation, which is to actually work out, okay, if I go this far along, how far up have I gone, etc. Which is why my own personal preference is to do it with the histogram, because I find that easier to visualize. You might prefer the cumulative frequency graph. So either way, you should actually get the same answers as I do with the histogram, okay? Because basically, this here is like visualizing the linear interpolation that we were doing. So we would be at 7. We have gone a certain amount along. We've gone 4 out of 7 along, and then we add that to 7. So that's basically what we're doing. And we just have to do that carefully, right? So anyway, this is your area, and this is that divided. If I do area divided by class width, I get frequency density, right? Because these two things times together to make the area. So 1 divided by 5 is 0.2. 5 divided by 3, I'm going to leave that as 5/3 because I actually want it to be written exactly. 13 over 2 is 6.5. 10 over 5 is 2. 2 over 5 is 0.4. So the sketch of the histogram goes 5, 10, 13, 15, 20, 25. Not worried about actually drawing it accurately along the bottom here, because I'm going to work out for myself how wide it actually is when it comes down to it. And then that goes up to 0.2. 5/3 is 1.666, so it's going to be a little bit bigger than this, obviously. So not that it matters if I've drawn it accurately or not, remember. And then this goes all the way up to 6.5. Not going to worry about it being to scale. This would be up to 2. And this would be up to 0.4. So this is my sketch of my histogram, right? This is clearly not drawn accurately. If I had graph paper and I was doing all of this really accurately, all of these would be the right size and in the right place. Okay, but you know, each of the areas is correct, right? 5 times 0.2 is 1. 3 times 5/3 is 5. 2 times 6.5 is 13. 2 times 5 is 10. And 5 times 0.4 is 2, right? So each of the areas is the right frequency, and they are kind of lined up in approximately the right place. So I'm actually going to take a little screen cap of this because I'm going to need to use it a few times. So I'm just going to pop it there and bring it back when I need it. So let's do the median first. So we need to do 1, add 5, add 13, add 10, add 2. So that's 6, 19, 29, 31. I suppose, okay, and there's also 31 days in May, so that works out. For the median, I'll do 31 divided by 2 because I need to shade half the area. That's 15.5. And if we go here, we'd have an area of 1, an area of 6, and then an area of 19, which is too big, right? Too big. So what we want for the median is we're going to have this 1 here, this 5 here, and then we're going to be partially into this box with an area of 9.5, right? 9.5. So what we want is we want that to have an area there of 9.5. When I'm talking about what do I mean this bit. We want that to have an area of 9.5. Right? And if I can work out what this number is here, that's my estimate of the median. Then I would have shaded, if I do all of it, I would have 6 and 9.5 is the 15.5, which I want. And so, okay, it's got an area of 9.5 and a height of 6.5. So how wide is this? How wide is it? Because if I know how wide it is, I'll just add that to 13. And then that's my estimate for the median. So I'll just briefly bring the calculator up. I'm going to do 9.5 divided by 6.5. And then I'm going to add that to the 13. And so I get 14.46, blah, 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 14.46. So my estimate for the median is 14.46, let's call it 462. Quickly just check. Okay, so they've in the answers they've rounded it to 14.5. So I'm just being needlessly accurate here. Right, just one sec. Right, okay, so there's my estimate for the median. So how are we going to estimate the interquartile range? Well, of course, we'll need the quartiles. I can just copy and paste that. Nice fresh histogram there. So my estimate for the lower quartile, I will do 31 divided by 4. So this is going to be for the lower quartile. So 31 divided by 4 is 7.75. And we'll actually be in this box again, except there'll be a lot less area to use up, because we've got an area of 1, an area of 5, and then this is going to have area 1.75. It's going to have area 1.75, that bit there. Right, so if I add these up from the left, I get the 7.75 that I want. And I'm talking about this area here. Has to be 1.75, and then the question is how wide is this? And again, I'll be adding it to 13, won't I? I'll be adding it to 13. So let me bring the calculator up and let me just do it kind of quickly. So 13 add, and then the area was 1.75, the height was 6.5. So if I do the area divided by the height, I'll get the width. And I'm adding that onto 13 to see that the lower quartile is 13.2692. So I'm going to write 13.2692. Right, upper quartile. So we need 3/4 of 31 this time. $23.25. Now we need to be careful. So now, what I can do is actually get rid of this. What you've got to imagine, by the way, is you could, your worst case scenario is you sketch this histogram 3 times. That's your worst case scenario. But it didn't take long to sketch it. It really does not take long to sketch it. You know, it's as quick as that. So anyway, we've got an area of 1, area of 5, so that's 6. Add 13 is 19. Add 10 is 29, is too big, so we are actually going to be partially into this box. Right, we want to work this out. So we are on 19, so we need this area to be 4.25. That's what we need. We want this area to be 4.25. Because then we would have 3/4 of the area shaded from the left, right? 1 add 5 is 6, add 13 is 19, add 4.25 is the 23.25 that we want. So on the calculator, let me just get rid of the calculator for a second to show you what I did. So I'm saying that this part here needs to be 4.25, so that, you know, if I shaded the whole thing in from the left, I would have 3/4 of the area, right? I'd have this 23.25. So my estimate for the upper quartile will be, I'm adding this bit extra onto 15, and the bit extra is the width of this rectangle that has a height of 2 and an area of 4.25. So 4.25 divided by 2 will be the width. Added onto 15 is 17.125. So my estimate is 17.125. And therefore we can estimate the interquartile range. So I'll be doing 17.125 minus 13.2692. Obviously I've been probably more accurate than you need to be. It's just you don't want rounding errors, so you want to leave the rounding to the end. So I get an interquartile range of 3.86. Let's go 3.86, 2 decimal places. Let's just check. Are we supposed to get 3.86? Well, let's actually see what we're supposed to get. 3.855 blah blah blah. I mean, if you actually look at the mark scheme, here's the 13.269 blah blah blah, which we got. Here's the 17.125, which we got, and okay, they rounded it to 3.9, and I rounded it to 3.86. So that's the method. Now that was for continuous data. Okay, now I'm well aware this video is already 27 minutes long, nearly 28. But what I'm going to do is, I'm now also going to talk about what to do if you have discrete data that is grouped. Okay, if you have discrete data that is grouped. And basically, you do what I just did here, with one additional step to begin with. Sorry, just checking Teams. There's one additional step if it is discrete data. Now, discrete data is just data which you reach a certain point of accuracy, and you can't be any more accurate. So one example is something like shoe size. So yes, okay, shoe size is you go and you have your feet measured, right? You go and you have your feet measured, and you do need an instrument to measure your feet. But your foot size can't be 17.138282 or 5.991 or something like that, right? It only comes in half sizes. It only comes in half sizes. So that's another sort of typical sort of thing that you would expect for discrete data. Whereas in this situation, you can't have halves, right? You either visited a discrete set of in terms of the number of homes that you could visit. That it can't be a fraction, right? That's the idea. It can't be a fraction. So I suppose what I'm trying to say in a bit of a roundabout way is it can be discrete data and still possibly have a fraction or decimal involved. For example, shoe size. However, the true distinction is we haven't had to measure. You don't get your feet measured and then someone rounds it. You just get your shoe size and that's it, right? You don't visit 3.6 homes and then round that to 4, right? You visited either 3 or you visited 4 or you visited 5 or however many. Okay, so this is discrete data. There's another question here, number of breakdowns. Well, that's discrete, right? You can't have half a breakdown, right? We aren't, there isn't a level of accuracy being applied. It's just something that we've counted, all right? So anyway, what is the thing that we have to do first? Because if I can tell you that and give you a very brief illustration, then I can end the video. So what you need to do is, with the grouped table with the discrete data, is you must first convert that table into a continuous grouped data table. So it should end up looking like this. It needs to be approximated as continuous. You use something called the continuity correction. That is in the textbook. Let me just tell you the page while we're here. Page 245. So what you do is in this, for example, in this situation here, 1 to 2, and then it's like there was a gap between 1 and 2 already, and then there's a gap from 2 to 3, and a gap from 3 to 4, 4 to 5, 5 to 6, etc. What we're going to do is we're going to kind of like pretend that we have got anything that would round to 1, so it would be 0.5 up to, let's call it S for the score, less than, I guess, 2.5. 2.5 less than or equals to S less than 5.5. What we're doing is we're basically making the endpoints meet and replacing this discrete data with intervals, pretending it's continuous. Okay, so we're pretending that you could have got a score of 2.53 and it would just so happen to round to 3. Right, that's what we're doing. Okay, and then 5.5 up to 10.5, and then 10.5 up to 20.5, and then you've got the same frequencies, so 3, 5, 7, and 8. So I'm going to write score and then continuity correction, and then basically this is now what you do. You basically forget about this. Forget about it. You're now doing this. You're now using this, and you do the exact same method. Okay, so you would use your lower boundaries as 0.5, 2.5, 5.5, and 10.5. You would not be using 1, 3, 6, and 11 anymore. You'd have class widths of 2, 3, 5, and 10. And you would do exactly the same, but you've replaced it with this. So that's what you do. Now basically the video could for all intents and purposes end here. But there is, unfortunately, a little bit of a complication, which most of the time, if you ever got a question where it was relevant, I just don't think it's necessarily going to come up anyway, but it is worth me pointing out, is how the continuity correction is applied will depend also on the context and the nature of the original data. So I'm really that there are two main things that could be a problem. One is it always 0.5 below and above? You know, one, okay, so we go to 0.5 because that would round up, and two, we go to 2.5. You know, we're talking about basically the upper and lower bounds, aren't we? But upper and lower bounds are context dependent. For example, if these, and I talked about this very briefly at the end of the first video, if these were people's ages, these aren't scores on a 20-sided dice. These are people's ages. Well, in which case the continuity correction would be 1 up to 3. 1 less than or equals, well, I guess A for age, let's call it A for age, up to but not including 3. 3 up to but not including 6. So this can happen when it's people's ages, and the reason that it happens in this way is because of how people think of ages. If you are, you know, 15 or 16 or whatever, and you know your birthday is tomorrow, you are still considered to be, you know, 15 or to 16 or whatever, right the way up until, and then all of a sudden it's your birthday and now you're the next age. So if you are 5 years old and 364 days, you're still 5 years old, which is why the continuity correction in that situation would be to go all the way up to but not include 6 rather than 5.5. So that's one problem. You can have one problem where the continuity correction, you need to be thinking very logically about what exactly is it. You know, most of the time it's going to be just use the 0.5, but you do need to be aware that if it's age, it wouldn't be 0.5. You would actually go up to the next age, rather than using 0.5. And then the other issue that can occur is, what do you do at the endpoints? In particular, what do you do if one of the endpoints is 0? You know, do you go down to minus 0.5? Or do you stick at 0 and just do a continuity correction on between 9 and 10, for example? Well, it turns out that it's that second option. Okay, you would not go to minus 0.5. Okay, if there really is again, and it's within the context, if there really is an absolute minimum that it could be, then that minimum would stay the same. That minimum would stay the same. And thankfully, and you know, remember at the end of the day, it's the whole thing, it's all just an estimate anyway. So even if you did do that, you're still just getting an estimate. It would not have an impact on your estimate for the median anyway, because the median is likely to be somewhere in the middle, where of course you're doing a continuity correction one side and the other, and then you've got your different areas of the boxes beforehand in your histogram anyway. So it wouldn't matter what was happening at the start and at the end. So those are just two things that are worth pointing out. Okay, so the video could end here, but if you want to keep watching, or if you want to pause and come back, or if you want to the best thing to do would be, why don't you have a go at this question? Estimate the median here. So you could pause and have a go, and then I can also show you this question. And let's just focus on part B, because I won't bother with part A or part C. Would you estimate the median here? Right, I'm actually gonna do these. I'm gonna go through this now. So I'm just gonna be doing the median for them both. The quartiles, you know, if you want to recap on how to do the quartiles, we'll just rewind the video and have a look at what I did here, right? Because how these are going to start is we're going to convert them. So already we're doing something that makes this even more of an estimate by approximating this to be continuous. Okay, so basically what we're going to do is we're going to say that this is really you know, naught So we're gonna stick with 0 at the bottom, but it's going to go to 9.5. This is going to go 9.5 to 19.5. This is going to go 19.5 to 29.5. This is going to go 29.5 to 39.5, and this is going to go 39.5 to 49.5. So then we have a class width and a frequency density. So the class width is, for this one, is 9.5, but all the other class widths are 10. And this is what I mean. It's like, it's not very, it's a little bit weird, because it's like, you know, should I have gone to minus 0.5 to make it more consistent? You know, there's an argument for that, and there's an argument against that. If you want the answer that you're supposed to get in terms of the mark scheme, then you are supposed to stick at 0. Yeah, but actually, as I actually said just before, it shouldn't make a difference, and I'll show you why it shouldn't make a difference to our estimate to the median. So anyway, frequency density. I need 3 divided by 9.5. So it's like 0.316-ish. Anyway, 8 divided by 10, 0.8, 2.4, 6, and 2.1. My sketch will be 0, 9.5, 19.5, 29.5, 39.5, 49.5. This goes up to a height of 0.316. This goes up to a height of 0.8. This goes up to a height of 2.4. This goes up to a height of 6. And this goes up to a height of 2.1. And you can see how, you know, lazy I'm being with my sketch here, because these are totally not to scale. But, you know, it doesn't matter. So the total frequency is 3 add 8 add 24 add 60 add 21 is 116. We want to halve that to get 58. So we want an area of 58 from the left. We have 3. We have 11. We have 30. Well, we have 24 in there. Sorry, I'm accidentally doing the cumulative frequencies there. So 3 add 8 is 11. Add 24 is 35. So add 24 is 35. Add 60 will be way too big. So we are in this box here. And then 58, take away 3, take away 8, take away 24. We want this to have an area of 23. This area here. And now hopefully you'll realize it just doesn't really matter what we've done down here. Thankfully, it just doesn't really matter. What matters is we've applied the continuity correction in a place where we can definitely justify applying it. So we're going to basically do, so our estimate will be 29.5 add, because remember the whole thing is now being replaced with this continuous approximation. So we're at 29.5, and we're adding this bit of width on, which will be given to us by 23/6. So 29.5 add 23/6 is 33.3 to 1 decimal place. Okay. Does 33.3 make sense for the median? Well, it's definitely got to be in this box, and it's got to be some way into between 30 and 39. So yes, common sense check says yes, it does. So hopefully you got 33.3. As for this one, we're going to instead make this go to 1.5, 1.5 to 3.5, and then 3.5 to 5.5. So we've got 0, 1.5, 3.5, 5.5. The class width is 1.5, and the height will be 18 divided by 1.5, which is 12. So we've got a height of 12. The class width is 2, and 7 divided by 2 is 3.5. And then 1 divided by 2 is a half. So there's my sketch of the histogram. 18 add 7 add 1 is 26, so I actually need an area of 13. Now that actually turns out to be in this first box. So in this situation, it would matter whether or not I'd stuck at 0 or if I had decided to go into the negatives. Now, as I said before, in a situation like this, you stick at 0. Exactly why is not all that clear to me, I'll be honest with you, but it is the answer that you're supposed to get in this textbook, which is the old S1. Now this book is just so much better than what you get in this book. There are so many more questions. This question here is actually a question from this book. Just gives you a lot more opportunity for practice, which I think is good. Anyway, we are 13 out of 12 the way along from 0. So I need to do 0 add 13 over 12, which is just 13/12, which rounds to 1.08. And if I go to the answer in the back of this book, 1.08 is the answer. So that book, and since this book was designed for Edexcel, the same as this book, you've got to assume that they haven't gone into the negatives. They've started at 0 and then applied the continuity correction where they join up, right? So then that begs the question, well, should I really have gone 0.5 up to, and then up to 20.5? And the answer is again, I think it depends on the context. I really do think it depends on the context. Hopefully it's just never relevant. Hopefully you don't get a question like this, because the overall strategies that are presented are not 100% consistent, I don't think. I think it's a lot more obvious if it starts at 0, then your new table will also start at 0. I think if these were rounded, these were say these were, you know, times or heights or something like this that had been rounded, then it makes sense to apply the continuity correction at both the bottom and at the top. So I think you've just got to hope you don't get a question like this. I know that doesn't necessarily fill you with a lot of confidence, but I would hope that if you did get a question like this, then the context in which you asked it makes it super obvious whether or not you should apply it at the top end and at the bottom end of the scores. Anyway, most of the time I think you just get a continuous one anyway. And if you get a continuous one, then, you know, the hard part is basically already done. You just need to remember how to do this. Applying a continuity correction and making sure that it's right within the context is, as I say, it just depends on it really does just depend on the question. Anyway, I hope this video has been helpful. I know it's been super long, so you know, you might not have watched it all in one go. But anyway, if you have any questions, just let me know. Thank you. Bye bye.